right, in this video, I'm going to walk you through how to do a couple examples in your balancing and classifying chemical reactions worksheet that I gave you. So as you can see on my screen, I have the first reaction that we're going to look at. This is the first reaction on this page that you already have, where we're reacting calcium hydroxide with hydrochloric acid, and we're making calcium chloride and water. So for your practice, you have to do two things. You need to balance this equation, and then you need to classify the equation. So we're going to balance first, doing the same strategy that we looked at in our last video. You're going to separate out your number of atoms or your types of atoms and figure out how many of each type that you have on each side of the equation. So what I want you to notice in this one, even though you are starting with a polyatomic hydroxide in calcium hydroxide, I want you to notice that it does not stay as hydroxide in the products. So you have to separate out your oxygen and your hydrogen atoms here. So you cannot balance it as a hydroxide. So we have calcium, we have oxygen, we have hydrogen, and we have chlorine. So in our reactants, we have 1 calcium, we have 2 oxygens because that hydroxide is in a bracket with a 2, and we have 3 hydrogens and 1 chlorine. If we do the same thing for our products, we're going to see that we have 1 calcium, we have 1 oxygen, we have 2 hydrogens, and we have 2 chlorines. So a quick check shows us our calciums are good, our oxygens are not good, our hydrogens are not good, and our chlorines are not good. So using our rules, you leave oxygen and hydrogen till last, and balance other atoms that exist first. So that means that we're going to look at our chlorine first. We're going to leave oxygen and hydrogen till the end. We have 2 chlorines in our product and only 1 chlorine in our reactant. So we're going to put a 2 here, which gives us 2 chlorines, but now it also gives us 4 hydrogens in our reactants as well, because that 2 that 2 coefficient means that we have 2 hydrochloric acid or 2 HCl molecules. So then we do our quick check. Our calciums still match, our oxygens do not match, our hydrogens do not match, but our chlorines now match. So now that we look, our calciums and our chlorines are both matching now. And so I'm going to suggest that we now look at our hydrogens. And this is fairly straightforward. Or actually, we could even look at our oxygens. Either one of them, I think, is going to match the other one. So if we look at our oxygen, and the reason I'm choosing to look at oxygen is because in the reactants, hydrogen is in 2 different places, but oxygen is only in 1 place. So it's going to be easier to balance the oxygens, and then by doing that, the hydrogens will probably balance themselves out. So in our reactants, we have 2 oxygens, and in our products, we only have 1 oxygen. So that means we need 2 in our product. So I'm going to add a coefficient 2 in front of this water. That gives me 2 oxygens, but now it's also giving me 4 hydrogens. So now we do a quick check. Our calciums match, our oxygens now are equal, our hydrogens are now equal, and our chlorines are now equal. So now that all 4 atoms have the same number on each side, our equation is balanced. The second part of your worksheet asks you to classify your type of reactant. So you have to look and see what is happening. Now, I'll give you a little hint. Whenever you have 2 ionic compounds, creating 2 ionic compounds, you almost always have double displacement. But let's just check. So if we take our calcium, we have a calcium here and a calcium here. And if we highlight these like we have those colored circles, we might see our type of reaction very easily. So I'm going to look at chlorine and chlorine here. And then that's not what I wanted. So if we look at it this way, it clearly looks like a double displacement. Now, this is actually a neutralization reaction, which is a form of double displacement. We didn't talk about that in your note, but what it looks like is that calcium and the hydrogen in HCl are switching places. And so that means that this is a double displacement. All right, so let's look at the second example on your work page. We have silver nitrate plus calcium chloride makes silver chloride plus calcium nitrate. So we're going to balance this first, and then we will classify. So what I would like you to do is hit pause and count up. All right, so in the reactants, we have 1 silver, we have 1 calcium, we have 1 chlorine. And I want you to notice that the nitrate, the NO3, stays as an NO3 from the reactants to the products. So we do not have to separate out the nitrogen and oxygen. We can just count it as one thing, and that makes it a little bit easier to balance. So using our rules, oxygen, hydrogen till the end, we don't have to do that because they don't exist here. And so when we do a quick check, our silver is good, our nitrate is not good, our calcium is not good, and our chlorine is not good. So you basically can pick any of these to start with. And usually by balancing 2, the third is going to balance itself out pretty nicely. So I'm just going to start with the nitrate, the NO3. We have 2 in products and 1 in reactant. So I'm going to add a 2 coefficient in front of my silver nitrate. Remember, we are not allowed to change the subscript numbers. By adding that 2, I now have a 2 silvers here, and I have 2 nitrates, which means my silvers no longer match up, but my nitrates do. My calcium, oh, I lied. My calcium is good. This is good. Oops. Okay, my calcium is still good, and my chlorine I haven't done anything with yet, so I still have to fix this. Now that I have those 2 checked, I'm now going to fix my chlorines. I have 2 chlorines in my reactant side and only 1 in my product. So I'm going to put a 2 here in front of the silver chloride. That's going to result in a 2 silver and 2 chlorines over here in products. So my silver is good. My nitrate, oh, what am I doing? My nitrate is good. My calcium is good. And my chlorine is good. So that means I've successfully balanced the chemical equation because everything's checked up. Second part of your assignment is asking you to classify. So I like to highlight things to help me see connections here. So I have my silver. I'm going to highlight yellow. I'm going to highlight my nitrate is blue. My calcium is pink. And my chlorine is green. Okay, so this is showing me very easily that my silver has switched partners with my calcium. So the metals have traded places, and so that means that we have a double displacement again. All right, we're going to do one more of these on your practice page, 1C. And again, what I would like you to do is hit pause and add up the number and type of atoms, and then just double check your work. Hit unpause to double check. All right, so if you add up your number and type of atoms, you're going to have 2 iron, 3 oxygen, 1 carbon in reactants, and 1 iron, 2 oxygens, and 1 carbon in your products. Now, this is an example where following the rules is going to actually create more work for you. So we can fix up iron without impacting any of the other elements, except we're going to have to fix it twice, because in order to fix oxygen, we're going to have to do something to the iron oxide or the iron 3 oxide. And then we're just going to have to rebalance our iron. Now, if you balance the iron first, you would just have to go and rebalance it later. It doesn't really matter. It's just an extra step. So I'm going to balance my oxygens. I have 3 oxygens in my reactants and 2 oxygens in my product. The only thing to do here is to multiply them both so that you end up with the same number. So the lowest, you kind of want the lowest number they both will divide into. When we have a 3 and a 2, the lowest number that you can multiply them or divide them both into is 6. So we're going to aim to get 6 oxygens on both sides of the equation. To do that, that means over here, I need to multiply this whole thing by 2. So that means I now have 4 irons, and you're probably seeing why I didn't want to touch iron first, and 6 oxygens. And then, so nothing is going to be happy here yet, but I can multiply this carbon dioxide by 3. So that gives me 3 carbons and 6 oxygens. So we finish off this step. Iron is not happy. Oxygen is happy. Carbon is not happy. But fixing fixing copper or carbon and iron are both easy fixes here. I can put a 4 in this spot and get 4 iron. And now iron is happy. And I can put a 3 here. And this carbon becomes happy. Still happy. Oh, that's happy. Happy and happy. Okay. And so now we have our balanced chemical equation, and we just have to classify. So again, I sometimes like to highlight so I can see a little easier what's happening. So I highlight my iron. I'm going to highlight my oxygens. And I'm going to highlight my carbon. Okay. When we look and we see what our colors are doing, we start with a yellow and a pink together and blue by itself. And then we end up with blue and pink together and yellow by itself. So that means that we are looking at a situation where carbon has replaced iron in bonding with oxygen. So that means that we have a single displacement. So what I'm going to suggest to you is that you continue to work through this worksheet, but don't do it all at once. Do a few every day, just like we practice the nomenclature in class. Take like 10 or 20 minutes a day and do maybe 10 or 5 of these examples, just so that you get better as time goes on. Suffering through doing all of them at once is not going to be really helpful. You want to give your brain a little break, do some, leave it alone, come back to it. Okay, so that is just 3 examples for how I would approach doing your worksheet. And if you have any questions, you can ask me those in our office hours.